All right, so these are the notes on circuits. And so current is the flow of electric charge. In a circuit, the current is the amount of charge passing a given point per unit time. So these two equations, this equation here, so let me make sure we understand. This equation here, this is the definition of current. It's the amount of charge that goes by a particular point, a certain amount of time. Okay, this is an equation that you simply just need to know. It won't come up very often on free response questions, but it'll come up pretty often on multiple choice type questions. All right. Now, when we talk about current, you can literally think of current as the particles of charge moving through a wire. All right. So if you go down here in the battery, okay, so the positive charges, they move from the positive side all the way around the circuit and then back to the battery. And what we will be using is conventional current. Okay, so make sure you write this down because I forgot to put this down. So conventional current is based on, what charge do you think conventional current is based on? Conventional current is based on the movement of positive charge. Okay, so just make sure you understand it's based off of positive charge. After that convention was started, it was soon found out that current is actually made out of negative charges. But as history goes, they just stuck with positive charges because it still all works. All right, so it's conventional current that we're going to be using, positive charges, but in reality, it's really negative charges, really electrons that are moving. All right? Okay, so the current I is measured in amps. Okay. Resistance is also something that we need to know. Resistance is a property of a circuit that resists the flow of current. Now, this is another important equation that you will probably not be using on your free response questions, but using a lot in the multiple choice part of your tests and quizzes. Okay. It basically tells us how much resistance there is to charge in any particular element. Or any particular device in a circuit. So if you notice the circuit on the bottom, it starts with a battery, it flows around this wire and gets through a resistor. A resistor does exactly that. It slows down or it resists the flow of charge. Okay? Alright, so resistance is measured in ohms, okay, and the symbol is omega. Resistivity depends upon the type of material in your resistor. So it's just a constant. It's this constant that changes based on the type of resistor you have. So on multiple choice tests, and I know this is coming up for your multiple choice test, what's more important is understanding how the length and the area affect the resistance. All right. So if we increase the length of the resistor, what happens to the resistance? It increases, okay? If we increase the area, this surface area right there, the resistor, what happens to the resistance? It decreases, okay? So those are the main things you need to know when it comes to this particular equation and how it relates to resistors, okay? All right. Now, the most important law in all of electronics that we will be dealing with is Ohm's law. It simply says that the potential, which is volts, is equal to the current times the resistance. All right? And on the bottom left there's a simple circuit that's run by a battery that has a current flowing through it and a resistor. Okay? All right. So the power equations we'll go over next time. Yes?
So do the normal wires have any resistance to them?
Good question. Every element that you put into a circuit has some sort of resistance to it. Okay, when you go on and you study more advanced electronics, where you study inductors and even capacitors, which we'll study, everything has some sort of resistance to it. In our class, for the most part, we'll just be looking at the resistors, well, the resistance in resistors themselves, not in capacitors. Even batteries have some resistance to them. Okay, and we'll
disregard the resistance due to batteries and wires.
Well, we'll talk about, okay, so I need to back up then a little bit. We will talk about the resistance due to batteries, which is called internal resistance. Okay, that'll come up a little later on. It's actually still pretty easy. Okay? All right. So here is, so the power equations I'm showing you here, that was a little premature. I'll show you those. We'll go over those next time. Okay? All right. Here's what I want us to do. I want us to go to the next set of notes and practice this thing called the VIR chart. Okay, the VIR chart is an example is already given to you on the bottom right. Okay, and we will apply it in a set of series resistors in series. Okay, now, so this next topic is resistors that are set up in series. So if you look at this setup right here, if the positive charge comes out of the battery, from the positive end of it, like that, okay, the current can only go through one resistor at a time. It can only go through that 2 ohm resistor, then that 2 ohm resistor, and finally that 4 ohm resistor back to the battery. All right? So resistors in series are exactly that. It's where the current can only flow from one resistor through one resistor at a time. All right? Now, the two important things to know are these. The current is the same in each resistor, okay, for resistors in series, and the voltages add up to some total. Okay, the other word that we use is that the voltage is distributed through the resistors. All right, so the first step in solving this problem, so in all of these problems, I want to know what the voltage, current, and resistance is in each of these resistors. That's essentially what the question is. So the first thing is to draw a vertical circuit. Now the vertical circuit is a little, is something a little unique, not necessarily to our class, but to solving these problems. But I think it's very important to draw them. Okay. So here's how I draw the vertical circuit. I'll take this circuit and I'll start on the positive end. The positive end of the battery is the longer end of the battery. Okay. So I'll start on that positive end, and I'm going to just draw a line up here. And I'm going to label that the positive end. That's where the charge starts, and that it's 40 volts. Okay? Then I'm going to follow the wire. It's almost like I'm taking this wire that's right there, and I'm going to bend it so that it's a vertical setup. So there's my wire that's represented by that part of the wire. Then the current goes through what resistor next? It goes through that first 2 ohm resistor. So I'm going to draw a little squiggly line to represent that 2 ohm resistor. Okay? Then after that 2 ohm resistor, the current flows through there and then goes through what? Okay, then it flows through the next 2 ohm resistor. Okay, so it flows through that 2 ohm resistor, and finally, then there's more wire there, and then finally, what does it do? Okay, it goes through that next 4 ohm resistor. We can just say 4 ohm. Okay? Alright, so so more wire, then a 4 ohm resistor, okay, then back to the battery. Okay, so back to the battery, but when it gets to this point of the battery, the voltage has gone down to 0 volts. We always end up with 0 volts when we get back to the battery. Alright, so this is the vertical version of that same circuit. Alright, now, some analogies that I want you guys to think of is that idea that this 40 volts is a 40 volt height. Okay, so I'm just going to replace that with the word height. Okay, or just show that that's what we're going to call a 40 volt height. Okay? All right. Now, so we drew the vertical circuit. Now we want to find the equivalent resistance. All right? Resistors in series are easy. All we do is we just take R1, R2, and R3, the resistors, and we just add them up. All right? So I'm going to find the equivalent resistance, and I'm actually going to redraw this like this. Okay, I'm going to take the 40 volt battery, and if I take each of those resistors and I add them up, I take the 2 ohm plus the 2 ohm plus the 4 ohm, I get a total resistance of what? Okay, I get a total resistance of 8 ohms. Okay, so what I do is I take all of those resistors and I replace them with an 8 ohm resistor. So this is still 8 ohms. or this is now 8 ohms. Okay? The voltage doesn't change, the height, in other words, doesn't change. It's 0 volts when we get to there. All right? Okay, so now what I'm going to do is I'm going to go to my VIR chart. Okay? Your VIR chart, most of the time you're going to have to draw it yourself. And the first thing I want to do on my VIR chart is to label R1, R2, and R3. So I'm going to label just right over here R1, R2, and R3. And they're going to be based off these resistors here, R1, R2, and R3. Okay. All right. And we want to figure out certain things about them, okay? We don't know the voltages of them, at least not yet. We don't know the currents going through them, but we know the resistances, okay? What is the resistance going through R1? Okay, 2 ohms. What about through the R2? What is it? 2 ohms. And what about R3? 4 ohms. Okay. Now the total resistance, this last row here, that's the same as equivalent resistance. So what's the equivalent resistance? 8 ohms. Now remember, we can only do that because this is a series set of resistors. All right. Now let's look at some other things. What about the total voltage? Do we know the total voltage? Yeah, it's 40 volts. Okay, so here's our rule. Our rule for the VIR chart is this. If you know 2 cells of a horizontal row, you use Ohm's law to find the third. So is there any horizontal row that I know 2 of the 3 cells? And when I mean the 3, I mean these 3 here. Any 3 in that box right there. Okay? Which one can I fill out? The total current right there. Okay, so if I use V equals IR, I can fill out V there as my total, because I know I got 40. My current is my unknown. R is 8. So my current must be what? Okay, so my current must be 5, and the units for current is amps. So I will fill this out by writing out 5 amps. Okay, now we go back. What I like to do is this. I like to go back to my vertical circuit and draw that 5 amps, okay, because I call that the battery current. That's the current coming out of this battery. So 5 amps are coming out of that battery. Remember what we said about current in series resistors? It says up here, current is what in each of the resistors? It's got to be the same. Okay, so this 5 amp current hasn't had a chance to break up. So it's going to be 5 amps through that resistor, 5 amps through that resistor, and 5 amps through that resistor. Okay, so I can fill out my VIR chart now. In each of those resistors, I got 5 amps. Okay. Now can I figure out the voltages on each of those resistors? Yeah, because I've got 2 of the 3 cells. Okay, so here I can take 5 times 2, and I'm going to get what? Okay, I'm going to get 10 volts. Here I'm going to get 5 times 2 again and get 10 volts. What about here in the third row? Okay, we get 20 volts. So the analogy that I'd like for you to use is this analogy. This height here, this first height here, we would say is 10 volts. Okay, this next height here is also 10 volts. And finally, this next height, the final height there, would be 20 volts. And so in the vertical direction, these 3 voltages add up to my total height of 40 volts. Okay, yes?
So do the resistors take away the volts as it flows through?
Yes, so voltage is, voltage we would say is used up at each of those resistors. Okay? All right. So another example would be resistors in parallel. All right, so the math for this isn't nearly as neat or tidy as in the previous kind. All right. So in resistors in parallel, the current can flow through more than one path. Okay. Voltage is the same in each path, and now we say current adds up or is distributed. Okay. The equation's a little different. Instead of just adding them up, we plug it into this equation there to find the equivalent resistance. Okay. So let's start out with our first step. What was the first step? Is to draw the vertical circuit, right? So we're going to start here from the positive end, okay, and follow the current as it goes around, right? So this is a 9-volt battery. So I'm going to start up here by drawing a 9-volt battery and my vertical circuit. So this first part is just this wire that's right there. But then as soon as that wire gets to this point, okay, it has how many paths that it can go to? Okay, technically it has 3 that it can go to. Okay, because even though it looks like it just gets split up to 2, it's split up into 3 different paths. All right, so I can redraw that like this. I got this one, this other resistor, and another resistor. I got 3 paths that it's actually following through. Okay, the length of the wires really doesn't matter. And when it gets down to here again, I'm going to be at 0 volts. Okay, so I'm going to label each of these 2 ohms. That's going to be my 2 ohm resistor there, another 2 ohm resistor, and my 4 ohm resistor. Okay. All right. So yeah, go ahead.
It's always going to be 0 volts at the end.
Yes. Yeah. Okay. That doesn't look like 2 ohms there. All right, so we've got 3 resistors here, so let's also label our 3 resistors R1, R2, and R3. Okay. We know the values of those resistors. They're 2 ohms, 2 ohms, and again 4 ohms, but now they're in parallel instead of being in series. Okay, so if you guys can get out your calculators too, that'd be a huge help. Okay, so get out your calculators. Okay. Now, if we look at these, right, we want to find the equivalent resistance. We want to find what this would look like if I took this 9-volt battery and broke it down or made it so that I had just one resistor. So we've got an equation for that. All right, and it's this equation up here. So my equivalent resistance is 1 over R equivalent is going to be equal to 1 over R1, which we'll call 2 ohms. Oops. I don't know why I did that. First time I ever did that. Okay, so 1 over 2 ohms plus 1 over 2 ohms plus 1 over 4 ohms. And you guys might get used to writing this out this way as well. Okay, you might also be writing it out like this. 1 R equivalent is equal to 1 over 2 plus 1 over 2 plus 1 over 4. Okay, can someone give me a value for that? What is it? 4/5, the whole thing, R equivalent? Okay, remember we always write things out in decimal form, so that's going to be 0.8 ohms. Okay, so for my total resistance, I'm going to put 0.8 ohms down in my VIR chart, and I'm going to label this 0.8 ohms. Okay? Is there anything else I know on my VIR chart? Is there anything else that I know? Okay, I know my total voltage is 9 volts. So now that I've got 2 of my 3, 2 of my 3 in that horizontal row, I can find my current, right? So someone put this in their calculator for me. To find out my current, I would take my voltage, which is 9 volts, and divide it by 0.8 ohms. Again, that comes from Ohm's law. What do you guys get when you put that? 11.25 amps. Okay. So we're going to plug that in here, my current, 11.25 amps. Okay. All right. So that's the current that's coming out of my 9-volt battery. Out of my 9-volt battery, I got 11.25 amps coming out. Okay. Let me use a different color pen here so it doesn't get all confusing here. Okay. Now, my 11.25 amps, it's going to split up in these three paths, and it's going to split up proportionally. But at this point, that mathematically, just by looking at it, it's probably too hard to just figure out what that would come out proportionally. So we got to go to something else. Okay. Now, remember what we said about voltage. Okay. It's kind of like the height of each of these resistances. Okay. So I've got 3 resistors, and I can actually figure out what the voltage is on each one because, number one, we were told that voltage is the same in each path. Okay. And also, if I go to the analogy and I think of these as each being 9 volts high, that's another way of thinking about it. All right. So what am I going to put in for voltage for these resistors? Okay. I'm going to put in 9 volts. Okay. So can I now figure out the current in each of them? Good. Yeah, I can do the same equation where my current is equal to my voltage divided by my resistance. So 9 divided by 2 is going to come up to what? Okay, 4.5 amps. Oops. 4.5 amps. And then 9 divided by 2 again is 4.5 amps. Okay. And then in this final one, R3, okay, 9 divided by 4 is what? 2.25 amps. So 2.25 amps. What do you notice about those currents? Yeah, okay. So notice what happens. The current, if I look at the current, some of the current, the 11.25, is going to split up and go in this direction. 4.5 amps is going to split up and go in that direction. Okay. And then in this direction, I'm also going to get 4.5 amps going through this path. So that leaves how much going through that path? Right there. 2.25 amps. Now, which branch is getting more current? Or which branch, I should say, is getting less current?
Oh, hi.
Hey, how's it going?
Hi.
Good.
Do we have a staff meeting today?
I thought we were... so the question again is, which branch had less current going through it? Yeah, the one with the greater resistance had less current going through it. Okay? Now, notice that 11.25 amps, it's split up into 4.5, 4.5, and 2.25 amps. When they come back together, when these 3 currents come back together, okay, when those 3 currents come back together, before it gets to the battery, what do you think the current is going to be when they come back together? Yeah, they're going to add back up to 11.25 amps. Okay? All right. So that's how we saw the difference between the resistors in parallel and the resistors in series. Okay? So, you know what? I think I'm going to do something a little different. Here's what I'm going to do. I'm going to stop this here. We'll test this out and see how this goes. So let's resume this and look at this next one. So this is the final setup on the final page of your notes there. Okay, so our first step. So there's our circuit. It's set up kind of a very interesting way there. So the first step is to draw a vertical version of that. Okay, so the vertical version, let's start off by drawing it out. I'm going to draw it right here beneath the other version. I'm going to say that that's a 120 volt battery. Okay, and I'm going to follow the current as it goes around. There's some wire there, and then what's the first resistor that it gets to?
2 ohms.
Yeah, it gets to a 2 ohm resistor. Then what does it do? Then it gets to a 1 ohm resistor. Okay. Then what happens?
Branches.
It branches off.
2 paths.
Okay. 2 paths to a 6 ohm resistor and another 6 ohm resistor. Okay, so this is the vertical version of this. So 6 ohms and 6 ohms. So let's label these. Let's label this R1, R2, R3, and R4. And do the same thing in our VIR chart. Have our different resistances labeled out. Okay, so this is called a combo circuit. It's got both a series and parallel. All right. First thing we should probably do is simplify it so that we get an equivalent circuit. Okay. What's the easiest part of it to simplify? If we look at just a circuit, so right there, the 1 and the 2. What are we going to do with that? Okay, we're just going to add those together. So now I've got a 3 ohm resistor. And on this side, I still have my 6 ohm. And I still have my 6 ohm. Okay, so I've redrawn it. This is still 6 ohms on this side. And this is still 6 ohms on that side. Like that. Okay, then what should probably be my next step? Okay, so I got those 2 6 ohm resistors. So let me find the equivalent resistance for the 2 6 ohm resistors. And I like to simplify that equation and make it look like this. I go 1 over 6 plus 1 over 6. And I get, that's going to be 2 6 or 6 over 2. Does that come out to just 3?
Yeah.
Okay, so 3 ohms. So that means in this equivalent one, I got this 120 volt battery, a 3 ohm resistor, and down here, this parallel set make, that's getting sloppier, another 3 ohm resistor. So finally I can do what?
Add those 2.
I can add those 2 because they're in series. So now I know my equivalent resistance is what?
6 ohms.
My equivalent resistance is 6 ohms. Okay, so my equivalent resistance, I can write these down. My R1, you know what, I haven't filled these in. This is 2 ohms, 1 ohm, 6 ohms, 6 ohms. We just finished saying our equivalent resistance would be also 6 ohms. Our total voltage is how much?
120.
120 volts. So what would my current be then? Okay, so 120 divided by 6. So let me put it in here. 120 divided by 6 gives me how much? Okay, that'll equal, I'll go to a different color here just to emphasize that. Let's go there. So that'll be 20 amps. So here's what that means. That means coming out of this battery, I've got 20 amps. I got 20 amps coming out of the battery, which is the same in my equivalent, or my vertical circuit is saying that 20 amps is coming out of the battery right there. It hasn't had a chance to split up yet when it gets to this 2 ohm resistor. So what is the current in this 2 ohm resistor? Yeah, it's got to be 20 amps. It hasn't had a chance to to split up yet. Then it keeps going. Has it had a chance to split up when it gets to the 1 ohm resistor? No, it's still 20 amps. Okay? So in my current here through R1 and R2, I should write, what current should I write through in R1 and R2?
20.
Okay, I should write 20 amps and 20 amps. So, remember my rule for the VIR chart. If I know 2 of the 3 cells, I can find the third. So what should this voltage be right here?
40.
Okay, so this should be the 40 volts. And this one should be what? 20 volts. So here's what I know. I know in this part and in this part, I've got 40 volts. I got 40 volts there and 20 volts there for a total height of this top part as being how many volts? 60 volts. The entire height should be how much? Okay. From the top all the way to the bottom, we get 120 volts. So this bottom height should be how much?
60.
So this bottom height should also be 60 volts. Okay. That height, notice, is the same for both for both resistors. Does that make sense? Okay. So I should have, what should I put down for my voltage for my R3?
60 volts.
Okay, I'm going to get 60 volts. And what about R4?
60.
Okay, 60 volts. So now can I figure out what the current is in my resistor? Yeah, I take 60 divided by 6. Divided by 6 on both of these. 60 divided by 6 to get an answer of how much?
10 amps.
10 amps. Okay. So each of these should be 10 amps. Now let's follow my current. My current goes through here. It splits up, and we said 10 amps go through there. Does it make sense that 10 amps have to go this way as well? Right? Why does it have to be 10 amps going through that way as well? Yeah, the resistance are equal, so the 20 amps should split up in 10 here and 10 there, and they'll recombine to be 20 when they get down to the bottom there. Okay? All right. So that sort of gives you an idea of how to start to solve some of those other problems. So here's what I want you guys to do now. What I want you guys to do is